Hello everybody, today we are going to be going over a mole and what it is. So to start off, I am going to have 1 mole of hydrogen. So 1 mole of hydrogen is equal to 6.02 times 10 to the power of 23 atoms of hydrogen. So that number, 6.02 times 10 to the 23, is called Avogadro's number. So whenever we are talking about a mole, it doesn't matter if it's hydrogen, it doesn't matter if it's oxygen, it doesn't matter if it's anything. When there's 1 mole of that, there's always 6.02 times 10 to the 23 amount of that. And I'll get into why that's important in a second. So based on the atomic mass of hydrogen, so if we look at hydrogen on the periodic table, so if you want to get out your periodic table, it's going to look something like this. You're going to have the hydrogen, the H there, and then you are going to have the atomic number, and then you're going to have the atomic mass down here. So the atomic mass is what allows us to convert between moles and grams. So we have the last piece of our puzzle here. We know 1 mole of hydrogen equals 6.02 times 10 to the power of 23 atoms of hydrogen. And we know that that also equals 1.008 grams of hydrogen, because of this number here. And that atomic mass is present on all of the elements on the periodic table. So let's go over another quick example here. So we know that 1 mole of O2, which is not the atom oxygen, but rather the molecule O2, which is a common way that oxygen is found in nature, is equal to, again, the exact same amount, 6.02 times 10 to the power of 23 atoms, or sorry, my mistake here, not atoms, molecules of O2. So again, we know that the actual amount of molecules is the same as the amount of atoms in hydrogen, because we know that 1 mole is always that amount of number. But now when we are looking at oxygen, I'm just going to tell you right now, has a atomic mass of 16. So we're going to use this number here, this 16, to find out how many moles of O2, sorry, how much 1 mole of O2 weighs. So there are 2 atoms of oxygen in 1 molecule of O2. So we need to multiply this number by 2 to get the amount of mass in 1 mole of O2. So we know that 16 times 2 equals 32. So we know that there are 32 grams of O2 in 1 mole. So lastly, I'm going to use a bit of a weird example here, but I want to try to explain that moles don't always have to be used on atoms and molecules. They can be used on anything. So if I have 1 mole of cows, like a cow that goes moo, I know that that's going to be equal to 6.02 times 10 to the 23 cows. Right? So again, this number is exactly the same as our past 3 numbers. But here, we don't have cows on the periodic table. So I just went and I looked up how much on average a cow weighs. Turns out it was 600 kilograms. So I just used that as the atomic mass. And if we use 600 kilograms in 1 mole, and we know in 1 mole there's that many cows. I did the math off screen, but it's going to equal 3.6 times 10 to the 26 kilograms of cows. So that kind of tells us why we typically use the mole for things that are at the atomic level or at the microscopic level. It's because when we use really big things, it just turns into this huge number. But on the contrary, when something's really small and we need so much of it just to equal an amount that we could use in something like a chemistry lab, that's when it comes in handy. Because, using one molecule of hydrogen, one molecule of O2, for example, is such a tiny, tiny amount that we would never be able to use it in any meaningful way. So I hope that explains things a little bit better, and please subscribe for more science content.